Hi, hello everyone. This is your educator, your tutor, your friend Sanjay Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button and share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Alright? Do visit our website also www.we-learning.in. You will be getting all these live sessions there. Along with that, you will be getting lecture notes also for each and every lecture. Okay, you can download them, you can learn from them. It is very useful. Do check it out. All right. Now, without any delay, let's get started with today's session. We were doing moving charges and magnetism, and this is lecture number 3. Now, this lecture is going to be very interesting, very beautiful lecture. What we are going to study in this is motion of a charge in a uniform magnetic field. Alright. And we'll also be seeing motion of a charge in a combined electric and magnetic field. We studied about Lorentz force that day. Then I told the motion we'll be studying after we learn about this motion in magnetic field. Then only we can study motion in both electric and magnetic field. Alright. So it is going to be very beautiful lecture. Take out your notebook, pen, get ready fast. Very logical. It is, you don't have to learn anything. You just have to understand how it is happening. All right. Now, let us start. So motion of a charge in a uniform magnetic field. So we'll see the path. Motion means we'll see the path of charge. Case 1, if theta is 0 degrees or 180 degrees. What is this theta here? It is the angle between velocity and magnetic field. Clear? Angle theta is the angle between V vector and B vector. Clear? So now, this is B magnetic field is in this direction, let's say in X direction, and velocity is also in X direction. Then only we can say theta is 0 degrees. Here if you see V and B both are in same direction, theta is 0 degrees. Or theta 180 degree means magnetic field is in X direction and velocity is in minus X direction. Right? Magnetic field is in this direction, velocity is opposite to it, that is 180 degrees. Now, what will be the magnetic force experienced by this particular particle? Let's say it's a positive particle, plus q charge it is having, m mass it is having. There also plus q and m. What will be the magnetic force? We have studied that a magnetic force on any charge is equal to q v cross b, right? Magnetic force is equal to q v vector cross b vector, right? So now if I just see, this is vector. If I see the magnitude, that will be QVB sine theta. Here theta is 0 degrees, that is QVB sine theta, let me just write, QVB sine 0 degrees, correct? That is F. From here what we got, F is equal to 0. In fact, if I just write F is equal to QVB sine 180 degrees, from here also what I am getting is F is equal to, from here also what I am getting is 0 only. Correct? Did you get the point? So that means you can write a note. If a particle is moving parallel to magnetic field, then it will experience no magnetic force. It will experience 0 magnetic force. So what will be the path? What will be the motion of this particle? It will keep on moving with the same velocity, right? There is no force. That means there is no acceleration. If there is no acceleration, there will be no change in velocity. It will keep on moving with velocity v in the same direction. All right. Got the point? Make a note of it. Particle will keep moving with velocity v in the same direction. In a straight line. This is the conclusion. Okay, I hope you understood case 1. Very easy it is. Just logical, complete. Next, if theta is 90 degrees, theta 90 means v vector is perpendicular to b vector. Yes or no? Suppose this is the magnetic field. What does this mean? What is the direction of magnetic field? Magnetic field is going inside the board. Okay, the lines are like this. Let's say this is marker, this is the point. So it is going like this. Okay, magnetic field is like this. V is perpendicular to B. So if I make V in this direction, it will be perpendicular. Let's make it. So this is a particle having charge q, mass m, moving with velocity v in this direction, and then suddenly a magnetic field appears. Okay, which is perpendicular to it. What will be the direction of this charge? We have to find out. What will be the force experienced by this charge? F is equal to QVB sin 90. Theta is the angle between V and B, sin 90, that is QVB. This is the force experienced by this. What is the direction of force? Right hand palm rule. Remember? Direction of force, direction of magnetic force, if you have to take out, keep your fingers in the direction of magnetic field, that is inside, and velocity, thumb in the direction of velocity, that is this, force is upward. So this will be Fm. Fm will be in the direction of, Fm will be in upwards direction, perpendicular to velocity. Clear? So now see, understand the motion. The particle is going in this direction. This force is upwards. That means acceleration is upwards. As simple as that. Acceleration is upwards. So now in this horizontal, there is no acceleration. So it will keep moving with this velocity in horizontal, but then there is an acceleration upwards. So what will happen? The velocity will start changing. The direction will start changing, right? So now from here, since the force is this side, the particle is moving like this. This force will attract this particle upwards. Since this force will attract the particle upwards, the particle will do a motion like this. Now here at this point, the particle will have velocity in this direction. The particle will have velocity in this direction. Force, magnetic field inside. Velocity upward, force is in the direction of palm, that is inside. Now here when the particle is there, when particle reaches here, this is the direction of force, right? Again now you see the particle is moving like this, the force is inside. So this force will actually attract this particle, right? It will again deviate the particle and the particle will start moving like this. Let's say the particle came here. Now when the particle is here, the velocity is in this direction now. The velocity is in this direction. Now see, magnetic field is inside, velocity is this, force is downwards. So this will be the magnetic force. This magnetic force will again pull this particle inward. The particle has to go that side, but it will go inwards towards the force. So again this will start deviating. The particle will come here. Okay. Let's say the particle is here. At 4 instances I am just telling you. The particle is here. The velocity is this. Now see. Magnetic field is inside. Velocity is downwards. Thumb in the direction of velocity. Magnetic field inside, velocity downwards. What is the direction of force? The direction of my palm, that is again inwards. Inward. The force here will be in this direction. This will again deviate this particle and the particle will again come back here. Again the same motion will happen. Again, once the particle comes here, again the same motion, again the same motion, again the same motion. It is the circular motion what is happening. What is happening? Circular motion. Clear? Now if you see, this is a constant force which is inside. If constant force means the magnitude I am talking about, not the direction. Direction is changing. Okay. Now this is QVB, it's the constant magnitude. Right? That means the acceleration is inward constant. When there is a constant acceleration inwards or a constant force inwards, a uniform circular motion happens. Right? And now if I ask the radius of this particular circle, how will we take it out? Understand from here, now this magnetic force is actually behaving as a centripetal force. Remember? 11th standard, circular motion. If a circular motion is happening, there is a force inwards. That force is centripetal force. And what is the value of that force? mv square by r. Are yes or no? Nahi aaya. Alright. Now see, magnetic force is equal to centripetal force this time, that is, in this particular case, magnetic force is equal to centripetal force. So Fm is equal to mv square by r. What is Fm? QVB is equal to mv square by r. V and V will be cancelled. 1v and here 1v will be cancelled. R is equal to mv upon qb. The particle will do circular motion and the radius of that circle will be mv upon qb. Very important. You have to remember this. Instead, there is no point in remembering. Just understand the logic. Fm will be equal to mv square by r. From there, you can always derive an exam. I never learned this formula. I always learned the concept. Alright, r is equal to mv upon qb. I hope you got this. Circular motion. When velocity is perpendicular to magnetic field, circular motion will happen where the radius will be mv upon qb. Now, what will be the time period of this particular motion? Time period means time in which this particle will complete one rotation, one round, one circle. Okay? Time in which this particle will complete one circle. We have to take out the time period. Time period is equal to time at which the particle, I hope you can see this, the particle will complete one rotation. So the time period is equal to, time is what? Distance upon speed, as simple as that. So now distance upon speed, that is equal to 2 pi r upon v. Are yes or no? If I know the radius of this, I can get to know the distance. Distance means this entire distance it is covering in one round. In one round, what it is covering? The circumference. Correct? Circumference will be 2 pi r. Velocity is v. Right? So here this will be 2 pi mv upon qb and this velocity v. Again v and v will be cancelled. What we got, time period is equal to 2 pi m upon qb. Again, very important. 2 pi m upon qb. Now, one thing to notice here is it is independent of velocity. How much ever velocity you give to a particle, it doesn't matter. The time period remains same. It only depends on the mass of the particle and the charge and magnetic field. right? So if I am talking about one particle of mass m and charge q, and it is there in a uniform magnetic field B, how much ever velocity you give, the time period will be same. Clear? Maybe the radius will become more. If you give more velocity, it will rotate in a bigger circle, but the time period of completing that one round will be same. If you give less velocity, the radius of the circle will be small, but the time period of completing one rotation will be same. Clear? For that particular particle in a uniform magnetic field. So now here what you have to see is it is independent of velocity. Very, very important. Done. Let's move to next. Case 3. If theta is any value, theta is angle between V and B, and we are telling that theta is any value. Okay. Let's say this is velocity V. Okay. This is at an angle theta from magnetic field. Magnetic field is horizontally. So from horizontal, this is angle theta. So now what kind of motion will happen? Very important case this is. Make a star here. Very, very important case this is. Alright. What will happen? Understand. First of all, this velocity, I can take two components of it. So there will be one horizontal velocity, that is V cos theta, one perpendicular velocity, that is V sin theta. We have actually divided this motion into two parts, where one motion we will see in x direction, one motion we will see in y direction. Alright, now see, we know that why we have divided it, because we have seen that if a particle goes parallel, first case 1 was particle is going parallel, case 2 was particle is going perpendicular. These two cases we knew. So we have divided this motion into the cases which we knew. Now we will try to get the answer. Okay. We know that if a particle goes parallel to magnetic field, it goes straight undeviated. Correct? In a straight line. That means the particle will move like this. First one motion. Second motion, we also know that if the velocity is perpendicular to magnetic field, the particle will do circular motion. So here this velocity is perpendicular. Because of this velocity, the particle will do circular motion. Because of this velocity, the particle will move straight. So what kind of motion will it be? The particle is doing two motions at the same time. Circular motion and moving in a straight line also. In horizontal also it is moving, in vertical it is doing circular motion. V perpendicular, that is V sin theta, will perform or will be responsible for circular motion. Correct? Circular motion. And V parallel, that is V cos theta, will be responsible for the motion in the direction of magnetic field. Clear? So now two motions are happening. This particle is doing a circular motion here due to V sin theta, right? And the same particle will be moving front also. So what kind of motion it will be? Understand. So this particle will actually move like this. It is a spiral motion, or you can say it is helical motion. Helical motion. Clear? So from here if you see, from here if I see, it will be a circle only, but the particle is coming towards me. Suppose I am standing here. If I see from here, the particle will be rotating like this, but it will be coming towards me also because it is having a horizontal velocity. Getting the point? So from here if this particle starts moving, in one time period, no doubt it will complete a circle. From here if I see, it will complete a circle, but the initial point and the final point will not be same. In horizontal it has covered some distance. From here it will start, okay? As it is rotating circular, it is coming front also. So the first point and the this second point, they are not same. They have covered a horizontal distance, but if I see from here, overlapping those 2 points, it will be a complete circle. Clear? I hope you got understood. So now understand, since two motions are happening, what do we need? We can find the radius of this, of the circular motion. We can find the radius. We can find the time period, in how much time it is completing one rotation. And we can also find this distance. This distance, this is known as pitch. This is known as pitch. Okay, this will be equal for everywhere, because in the same time in which it is completing one circle, in the same time it is completing this. So the time period for the circle will be same, and in the same time period it is covering the horizontal distance also. So these pitches will also be equal. Clear? This distance is known as pitch. Let's find. So radius will be, if I want to find the radius, again this circular motion is happening due to perpendicular velocity. Here, remember this formula. Remember it this way, where this V is V perpendicular. Radius is equal to mv perpendicular upon qb. Radius is equal to mv perpendicular upon qb. So here R is equal to mv perpendicular upon qb, that is equal to mv sin theta upon qb. Clear? Because the perpendicular velocity is responsible for the circular motion. You can derive also, not a problem. Q V. Now the velocity which we are talking about is V sin theta. Q VB is equal to m V sin theta whole square by R. And QVB sin theta, one more sin theta will come, right? That is sin 90 degrees. Angle between velocity and magnetic field. Here angle between this velocity and magnetic field is 90 degrees. So say this sin 90 will become 1. So this will be QV sin theta B, that is equal to mv square sin theta, sin square theta divide by R. V ने V को मार दिया, sin theta ने sin theta को मार दिया. From here we got R is equal to Q, R is equal to mv sin theta mv sin theta by qb. The same we got. Okay, so always remember the radius is mv perpendicular upon qb. I'll write here also so that you remember always. Remember this way. Remember this way. Now, so radius we got, time period 2 pi m upon qb. Time period is independent of velocity. Time period is independent of velocity. Next, you can derive also. See, T is equal to distance. Distance is 2 pi r. R is mv sin theta by qb. Distance upon speed. Speed is v sin theta. 2 pi m upon qb. You will get the same. Okay. Time period is always independent of velocity. So now we need to find the pitch. Pitch means in one time period how much horizontal distance the particle has covered. In one time period, the horizontal distance the particle has covered. Clear? Now see, or instead of horizontal distance, you can write the distance which the particle has covered in the direction of magnetic field. Okay? Now see. So pitch is basically this distance, horizontal distance, right? Horizontal distance is due to horizontal velocity and distance is speed into time. So this velocity into time period. Pitch is equal to, that is equal to V parallel into, let me write speed into time. This is responsible because of V parallel into time. That is V cos theta 2 pi m upon qb. Again I am telling you, no need to remember this formula. Only remember this, V parallel into t. Okay? So this you can properly write it as 2 pi m V cos theta 2 pi m V cos theta upon qb, that is the pitch. But I'll always recommend to learn this formula. All right. Pitch is equal to V parallel into T. Done? We'll go further. Note it down. Next. Let's see a question. So now magnetic force on a particle, motion of a particle in magnetic field, we have seen all the three cases. We have seen horizontal, we have seen perpendicular, we have seen if it is in any angle. Okay. Now let's see the questions. A proton moves with a velocity of 4 into 10 power 3 meter per second in the magnetic field of 1 Tesla at an angle of 60 degrees with the magnetic field as shown. So this is a proton. So this charge is this Q and M. How much will be the charge? 1.6 into 10 power minus 19 coulomb. How much will be the mass? You should remember 1.67 into 10 power minus 27 kgs. 1.67 into 10 power minus 27 kgs. Clear? So this is a proton. Magnetic field is given as 1 Tesla. Velocity is given as 4 into 10 power 3 meter per second at 60 degrees from the magnetic field. Find the trajectory, radius, time period and pitch. So what will be the trajectory? Since it is at some angle, the trajectory will be helical motion only. Right? See here, there will be again two components. One will be this, one will be this. Horizontal component will be 4 into 10 power 3 cos 60, right? 4 into 10 power 3 cos 60 degrees. That is equal to 2 into 10 power 3 meter per second, correct? This is 4 into 10 power 3 sine 60 degrees. That is equal to 2 root 3 meter into 10 power 3 meter per second, correct? This 2 root 3, see sine 60 is root 3 by 2. Root 3 by 2 coming here, 2 2s are 4, 2 root 3 will be the answer. 2 root 3 into 10 power 3 meter per second. These are two different velocities. This velocity is responsible for the circular motion. This velocity is responsible for the motion in horizontal direction or in the direction of magnetic field. So since both the motions are happening, it will be a helical motion. The trajectory is helix, correct? Or helical motion. Now, next is, so this we have told, radius we have to tell. Radius, what will be the radius? mv perpendicular upon qb. Radius is equal to mv perpendicular upon qb. Let us do it in the next page. R mv perpendicular upon qb. That is equal to 1.67 into 10 power minus 27 into V perpendicular is 2 root 3 into 10 power 3. 2 root 3 into 10 power 3 divided by 1.6 into 10 power minus 19 into 1 Tesla. Tesla is the SI unit. Okay, so we don't have to convert anything here. Everything is in SI unit. What will be the answer? I am going to find out the approximate answer. You can find the exact answer by using calculator or however. So this 1.6 and this 1.67 I am going to cancel because they are nearly equal. Okay. Then this will be 10 power minus 19 going up 10 power 19 plus 3 10 power 22 10 power minus 27 into 10 power 22 10 power minus 5. So this will be 2 root 3 2 root 3 into 10 power minus 5 meters. Everything is in SI unit. So we'll be doing in SI unit, meters. Clear? That is the radius of that circle. Now time period they are asking. What is the time period? 2 pi m upon qb. It is independent of the velocity. 2 pi m upon qb, that is equal to 2 pi into 1.67 into 10 power minus 27 divided by 1.6 into 10 power minus 19 into 1 Tesla. Correct? From here, again this and this I am cancelling. Approximate answer I am taking out. Okay. So this will be 10 power minus 19 going upwards, 10 power 19 minus 27 plus 19, that is minus 8. Correct? So 2 pi into 10 power minus 8, 2 pi, pi is 3.14, 2 into 3.14, 6.28. 6.28 into 10 power minus 8 seconds. Correct? 6.28 into 10 power minus 8 seconds will be the time period. Very fast it is happening. Right? Now, we have to find the pitch. Pitch is V parallel into time period. V parallel into T. That is equal to, what is V parallel? 2 into 10 power 3. 2 into 10 power 3 into time period is 6.28 into 10 power minus 8. Correct? 2 into 10 power 3, time period is 6.28 into 10 power minus 8. Just see if everything is correct. Alright. 10 power minus 8. 19, 22, 10 power minus 5. Radius 2 pi m upon qb, 2 pi into mass upon qb. So this will be 2 6 are 12. Okay, 2 8 are 16. 6 1 carry 2 2 are 4 1 5. 2 6 are 12. 1 2 5 6. 12.56 into 10 power minus 5 meters. Correct? Or you can write 1.256 into 10 power minus 4 meter also. I hope you got it. Just see. If there is a calculation mistake, you can ignore it. Main important thing is the concept. Alright. Done. So we have got the trajectory, we have got the radius, we have got the time period, we have got the pitch. Shall we go further? Note it down. Okay. Next question. A particle having charge q and mass m moves with a velocity of v is equal to 6 I cap plus 8 j cap. In magnetic field, b is equal to 3 k cap. Find trajectory, radius, time period and pitch. How do we do this? Let's do. So they are telling that b is 3 k cap. Velocity is 6 I cap plus 8 j cap. So all the three directions they have used, x, y and z. And velocity, this magnetic field is in z direction. So what I am going to do is, I'll take this as x, this as y and this as z. So instead of showing it like this, I can show z as this also. Yes, sir. Z is basically, this is x, this is y, z is basically which is coming out, right? That is only z. I can show z like this. So this magnetic field 3k is in z direction. So this magnetic field is coming out like this. Out of the board it is coming. If it was minus z, I would have made cross sign, right? Into the board. Okay. So now this is b. B is equal to 3k cap. Velocity is 6 I cap plus 8 j cap. What does this mean? This magnetic field is coming out, right? I cap is in this direction, j cap is in this direction. So if this is the particle, the main thing in physics is to make the proper diagram. If you have made correct diagram, you can never do any question wrong. Okay, see here, this I cap means one velocity is in this direction, that is 6 I cap. One velocity is in this direction, that is 8 j cap. Correct? Instead of writing I cap j cap, I can, since I have already shown the direction, I can write 6 and 8. Here also I can write 3. I have already shown the directions, right? Understood? Now see, we have to find the trajectory. For that we need to see what is the angle between velocity and magnetic field. Don't do like this, that oh, this velocity is perpendicular, so this will do circular motion, this velocity is horizontal, so this will go in horizontal, it will be a helix. People, students who are thinking that way is wrong. This is not vertical, this is not horizontal. With respect to magnetic field, we are talking every time, whenever we are talking about angle between velocity and magnetic field, we are talking about angle between them, right? Here if you see, velocity is upwards, magnetic field is out of the board like this. What is the angle between velocity, this velocity and this magnetic field? 90 degrees. Here also if you see, velocity is in x direction and this is in z direction. What is the angle between this velocity and this? 90 degrees. Both the velocities are 90 degrees from magnetic field, right? The velocities are in xy plane. Magnetic field is in z direction, 90 degrees. Both the velocities are perpendicular to magnetic field. So what we'll do, we'll take the resultant of this velocity and solve the question. Resultant, what will be the resultant? Under root of 8 square plus 6 square, that is equal to 8 8s are 64, 6 6 are 36, 64 plus 36 is 100, root of 100 is 10, right? This is 10. So now this 10 meter per second, this 10 velocity is perpendicular to B. What kind of motion it will be? We have only one velocity that is perpendicular to B. What will be the motion? Circular motion, right? Circular motion. Whenever velocity is perpendicular to B, we have circular motion. See here. So this finally we'll get something like this. This is the particle, let's say. Having velocity this, that is 10. Correct? Magnetic field is coming out. So now fingers in the direction of magnetic field, thumb in the direction of velocity. If I do like this, fingers in the direction of magnetic field, thumb in the direction of velocity, my force is this side. Correct? Perpendicular to this, the force will be this side. Magnetic force. So this particle will start changing its path. The particle will come here, the force will be inside. The particle will come here, the force will be inside. The particle will come here, the force will be inside. The particle will come here. It will actually do a circular motion. Clear? Remember, velocity perpendicular to magnetic field means circular motion. The particle, since velocity is, instead of using this much brain, just write, since V is perpendicular to B, the particle will perform circular motion. So since it is doing circular motion, we can easily find the radius r is equal to mv perpendicular by qb. That is equal to, m is given as m, v is 10, q is given as q, and b is 3. Right? 10m upon 3q. Clear? Now, what will be the time period? 2 pi m upon qb, 2 pi m upon 3q. Or let me write qb. Some people will be like, from where this 3 came? 2 pi m upon 3q. Clear? This is the radius, that is the time period. What? We got the trajectory, circle. We got the radius, we got the time period. What will be the pitch? Pitch is equal to 0. Since there is no V parallel. Clear? I hope you got this. So whenever you get a question, always see the angle between V and B. Do not get confused that, oh, this is perpendicular, this is horizontal. Velocity you have to see with respect to B. Done? Understood? Let's go further. So now, motion of charged particle in combined electric and magnetic field. I am going to go fast here. Electric field motion we have seen in first chapter. Magnetic field motion we have seen right now. Motion of charge in magnetic field. Now it is the combination. We'll go fast. Okay. See, case 1, electric field. Now there are many cases possible. Some around 10, 12, 15 cases are possible. Okay. We are only going to talk about 2 major cases. And in these major cases, 2 cases, inside there will be some sub cases. Why I am solving these sub cases? So that your mind will open up. You will understand how to do these kind of questions. Okay. Once you understand the way to do these kind of questions, you can do any combination. Okay. So first is E and B are parallel. So since E and B are parallel, then first sub case is charge is at rest initially. So now E and B are parallel. This is the charge which is at rest. So what will happen? How much? See, there will be forces on this charge due to the fields. We know that when the charge is at rest, how much is the magnetic field, magnetic force on that charge? 0, right? Here, Fm is equal to 0 since charge is at rest. Clear? So which force will be there on this? Electrostatic force. F capital E, I'll write. And the direction of electrostatic force will be in the direction of the field. Why? Because it's a positive charge. Clear? So the charge will start moving in this direction. parallel to both the fields. Now since there is force, acceleration is equal to Fe upon m, and what is Fe? What is electrostatic force on any charge? That is charge into electric field divided by m. That is the acceleration, right? So this particle is basically, now this is a question of 9th standard. Motion in 1D. It is doing a straight line motion. You can do anything on this charge. You can find all the data, all the details of this charge, right? We got to know the acceleration also. Now if I want to know the final velocity after time t, v is equal to u plus at. What is u? 0. At is q e by m into time t. Correct? If I want to write s, after time t, how much distance this particle has covered? Again, it is motion in 1D, right? Ut plus half at square. U is 0, that is half into a into t square. Got the point? From where we got these two? V is equal to u plus at, and this, or I'll write, otherwise some people will think from where did it come? V is equal to u plus at. This is S is equal to, 1 second. Clear? This is the formula. So since it is doing motion in 1D, you can get all the details of it. You can get the time, you can get the velocity, you can get the distance, whatever you want. Next, charge is moving parallel to electric field and magnetic field with initial velocity v0. Same thing, what we got here, the same thing. It's just that here u was 0. Here u was 0, here u will be v0. Rest everything is going to be same. Why? Because we also know that when the charge is moving parallelly to magnetic field, magnetic force is 0. QVB, first case we saw today, right? QVB sine theta. When theta is 0, QVB sine 0, that is 0. So now, here magnetic force is equal to 0 since particle is moving parallel to magnetic field. Clear? So which force will be there on it? Electrostatic force. So because of this electrostatic force, again acceleration will be there, that is electrostatic force upon mass, that is QE by m. Again, it's motion in 1D. The same thing, it's just that this time initial velocity v0 is there. So v, if you want to write, v is equal to u plus at. S is equal to ut plus half at square. Clear? V square is equal to u square plus 2as. Instead of, in place of a, QE by m. All the three equations will be valid here. Done. Next, charge is moving perpendicular to electric field and magnetic field with initial velocity v0. Now this is important. Why? Because this time both the forces will act. This time both the forces will act. See here. This particle is perpendicular to magnetic field. When the particle is perpendicular to magnetic field, it does circular motion, right? And this electric field, because of this electric field, electric force will be in this direction. Continuous. Magnetic force will keep changing the direction, right? But electric force will be in the same direction. Initially, magnetic force will be inside. Initially. So now see, the particle will do circular motion like this. From here it will go inside the board, then come outside the board, then inside the board, outside the board, like this it will do. Because of electric field it will do horizontal motion also. So from here it is coming towards me. Right? Now some people will think it's the same motion what we studied when the particle was at some angle with magnetic field, right? But there is a difference. When the particle was at some angle with the magnetic field, there were two velocities, which was this and this. V parallel, V perpendicular. Because of this it was doing circular motion, because of this it was going like this. So it was a helical motion. Here also there will be helical motion only, no doubt in that. But here the pitch was constant, right? Because in horizontal there was no acceleration. This velocity was not changing. Here in horizontal there is an acceleration. This parallel velocity will keep changing. So the pitch will keep increasing. Here the helical motion will happen, but with increasing pitch. So helical motion will happen, but with increasing pitch. Clear? See this pitch. Okay, let me make it proper. I shouldn't make the circle also big. Okay. Got the point? Now see the pitch. Let's say this is P1, this is P2, this is P3, and so on. So here P3 will be greater than P2, will be greater than P1. Why? Because due to Fe there is an acceleration in horizontal. Clear? Now, so because of this V0, circular motion will happen. I can write the radius m V0 upon QB. MV perpendicular upon QB, V perpendicular is this. Because of this Fe, AX is equal to QE by M. Motion in X because of this AX acceleration. So because of this AX, now you can write V is equal to U plus AT, S is equal to UT plus half AT square. Alright. So these two things you have to write. Time period. For one circle, the time period is independent of velocity. Okay. 2 pi m upon QB. Done. For pitch, you can use S is equal to UT plus half AT square. The same. Understood? So now any question if they ask on this, you can find. Okay. Let's go further. E and B are parallel. Charge is moving at an angle theta from E and B. Again, it is simple only. So it is at some angle. Now what will happen? The difference. This is V0 cos theta. This is V0 sin theta. Due to this V0 sin theta, there will be circular motion. Now here, initial velocity is V0 cos theta, but there is an electric field. Because of this, there is electric force also. Because of this, there is an acceleration also. The same thing. So here, it will be a helical motion with increasing pitch. Okay. Helical motion with increasing pitch. Here also you can write helical motion with increasing pitch. See, helical motion happens if there is a horizontal velocity also. Here initial horizontal velocity was 0 because the particle was going like this, but later it got horizontal velocity due to a acceleration in x, that is this. Clear? Here the only difference between the previous one and this is because of this v sine theta, the circular motion will happen. So I can write the radius mv perpendicular, that is v naught sine theta upon qb. I can write the radius. I can write the acceleration at x, that is qm upon, qe by m. Both things will be same, but the only difference is here at x we have got an initial velocity v naught cos theta. Okay. Make the diagram, resolve the velocities, you will get, make the components of velocities, you will understand. Just remember v perpendicular, v parallel. Okay. In x, whenever you are solving, always use v parallel. So if I want to write, let's say vx, final velocity in x direction, v is equal to u plus at. U plus at means v naught cos theta plus qe by m into t. This is u plus at. If I want to write s in x direction, at some time t, how much distance the particle has covered in x, ut plus half at square. Clear? This is the distance in x. Time period of completing one rotation will be 2 pi m upon qb only. That is independent of velocity. In the previous one also, if you want, I should write vx. Vx is equal to only at. Sx is equal to half into at square. Okay. Here initial velocity was 0. Here there was some initial velocity. Done. Next. E and B are perpendicular. Now this is something which is very, very, very important. This is there in your boards. Okay. E and B are perpendicular. Now the first case, basically first case is there in your boards. E, B and V are mutually perpendicular to each other. Mutually perpendicular means, let's say this is an apparatus what I am making, okay, where you will see E and B are perpendicular, and then I'll throw a particle perpendicularly to both of them. So this is a positive plate, this is a negative plate. That means electric field will be from positive to negative, that is downwards. If I give a perpendicular magnetic field at the same region, let's say like this. So electric field is downwards, magnetic field is inwards. Both are perpendicular, right? This is magnetic field, this is electric field, perpendicular. Now if I throw a particle perpendicular like this with V naught, so see this and this are perpendicular, and this inside magnetic field and this are also perpendicular. All the three are mutually perpendicular to each other. One is in X, one is in Y, one is in Z. Basically this is minus Y, this is minus Z, this is X. Okay. Now what will happen? See here, this particle will experience two forces currently. One force is due to magnetic field, one force is due to electric field. Now due to, at this particular instant I am talking about, let's say the moment it goes inside, it is having velocity v naught. At this particular instant, there are two different forces which are acting on this particle. One is magnetic force. What is the direction of magnetic force? Let's say magnetic force is in, the magnetic field is inside, velocity is this. Magnetic force is upwards. Electric force in the direction of electric field, because it's the positive charge. The line of force is same. This is upwards, this is downwards. So there will be a net force on the same line, right? What will be the net force? It depends on which force is greater. If Fm is greater than Fe, the particle will go upwards. If Fe is greater than Fm, the particle will go downwards. Now see, there is a straight velocity also, and there is no acceleration, there is no force in horizontal. That means this velocity will always be constant horizontally. So particle will go upwards also and horizontally also. So basically, till the time it crosses this magnetic field, it will be like a parabola. From here it will be like a parabola like this. So if this will happen only when Fm is greater than Fe. Are yes or no? If Fm is greater than Fe, the net force will be upwards. The particle will go upwards. This will happen when Fe will be greater than Fm. Note it down, make a note of it. Alright. But what if Fm and Fe are equal? What if Fm and Fe are equal? If Fm and Fe are equal, both will cancel out each other. The particle will have only one velocity, that is V naught in straight direction, horizontal direction. The particle will go undeflected. The particle will go undeflected, and this will happen when Fm is equal to Fe. This particular setup, this particular apparatus is known as velocity selector. What is this velocity selector? Velocity selector apparatus. It is a kind of filter where we actually throw charged particles with some velocity. Okay? Perpendicularly we will throw. Then the particle which are having velocity, this Fm, okay, let me talk about the velocity first. See, if Fm is equal to Fe, what does this mean? QVB is equal to QE. QVB sin theta, theta is 90 degrees because perpendicular, QVB is equal to QE. So from here, Q and Q will be cancelled. What we got as V? V is equal to E by B. If this is the case, then if Fm is greater than Fe, here it will be QVB is greater than QE. That is V is greater than E by B. If Fm is less than Fe, QVB is less than QE. So V is less than E by B. Understand? If V is equal to E by B, particle will go straight. Undeflected. Particle here, if V is greater than E by B, Fm is greater, particle will go in upward parabola. Here, particle will go in downward parabola. Got the point? Very logical to understand, right? So this is basically a filter where we send particles with a velocity perpendicular to both the fields. First of all, we will keep both the fields perpendicular. Then we will send particle such that Q, E and V all are mutually perpendicular. Then the particles which are going upwards, okay, we will understand for these particles the velocity is greater than E by B. Particles which are going undeflected, these particles are having velocity E by B. Particles which are going downwards are having velocity less than E by B. So for selecting particles with different velocities, we use this apparatus. Velocity selector, from the name only. For selecting particles with different velocities, we use this particular apparatus. Okay. So different velocity particles will have different path. We'll get to know, we'll collect these particles or we'll use these particles as we want. Okay. Understood? Easy it is. This you should know. This is the last. E and B are perpendicular. Case 2, second, charge is initially at rest. So here E and B are perpendicular. I have taken E in Z. That means it is basically coming out. B in this direction. So now what will be, charge is initially at rest at the origin. This is the charge which is at the origin at rest. What will be the path? Now this derivation of this particular path or the trajectory is not in your course because it is higher order mathematics. Okay, but still I'll tell you what will be the trajectory. Remember it, learn it. From logic, let's understand. This is the particle. Initially, there will be no magnetic force because the particle is at rest. Electric field is in this direction. So what will happen? This particle will start moving in the direction of electric field. This particle will start moving in the direction of electric field. Then when this particle will start moving in the direction of electric field, because of this B, particle B is this one, particle is this. B is in this direction, velocity is this direction, wait, this, velocity is in this direction, force is this side. Now, okay, let me take this electric field in minus Z, okay, these are perpendicular only. So what will happen in this case, the force will be like this, the particle will go like this. Now it will try to complete a circle, but it will not. Okay, one second. Let me do one thing. It will become easy. Let's say this is B. Let's say this is E. Now try to understand. Because of this E, the particle will try to go upwards, but this B is there, which is in Z direction, or let's say outward it is. Okay. So now B is outward, velocity is upward, force will be inside. So this particle is actually going upwards, but there will be a force inside because of which it will deviate. Magnetic field, velocity, force is inside. So it will deviate. So it will try to complete a circle because of this, right? But this electric field will constantly keep pushing it upward. So because of which it will not complete the circle, or it will not complete one rotation. It will again start rising because of this electric field. Again this magnetic field is always acting, right? It will again deflect the path. Again this electric field will make it upwards, again it will deflect the path. Like this the path will be. This path is known as cycloid. This trajectory is known as cycloid trajectory. Alright. Derivation of this trajectory is not in your course because it involves higher order mathematics. Clear? So remember this trajectory. Understood? I hope you understood today's lecture. It was completely logical. There was no need to learn anything. Alright? Just practice it once. Go through this lecture again. See your notebook again. Revise it again. Very easy it is. Alright? In the next session, we will be doing cyclotron, which is again based on combined electric and magnetic field, motion of particle and combined. Okay, very interesting this will also be. Principle, construction, working, uses and limitations we will see. Alright, I hope you liked today's session, you understood today's session. If you liked it, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Alright, do visit our website www.v-learning.in. All these live sessions what we are giving here you will be getting there. Along with that you will be getting lecture notes also, which you can download, which you can read. It will be very useful for you. Do check it out. Okay, we'll meet up in the next session. Till then, keep learning from V Learning. All the best.